Okay, this is lesson 2.1, properties of radicals. So what we're going to do is we're going to take any function, whatever it happens to be, and graph the square root of it. So for instance, so if you have y equals f of x right there, we're going to graph y equals root of f of x, whatever it happens to be. This is just a generic way of doing it. So for instance, let's start with 1. Graph f of x equals negative 2x plus 1. So it's linear. We know our y-intercept is positive 1. The slope is negative 2, 1. So we go down 2 over 1. So you can see the black line here is y equals negative 2x plus 1. Excuse me. And what we want to do is we want to take and graph the square root of it. Now, something you got to realize is you can't take the square root of a negative. So everything below the the x-axis here is gone. So it's going to look like this. And you can actually just do this with a table of values. But there's some methods to do this. So what we call is we look at, let's say, invariant points. Invariant points is a point that does not change on both graphs. We did this back in grade 11 when we did quadratics. And so we can do this. So our invariant points here is going to be 0, 1, because it's the same point on both those graphs. And we also have to look at where does this start? Wherever it crosses the x-axis, so in this case, it's 1/2 0, is also where our new graph is going to start with. So that point's the same there. Now, so what happens between 0 and 1? So what happens between 0 and 1 on the y-axis, right? If you actually graph it out, the values are larger, so you draw the square root curve slightly above the line. So you can see there's like a slight bump right here, a slight bump right there. Okay, so then, let's undo that thing there. And what happens when it exists? Oh, we know it doesn't exist below the x-axis. And when we are going greater than 1, so we're talking about here everything greater than 1, right? It's just a slow curve off into this direction here. So this is the general shape. If it's linear, right, and this has negative slope, it's going to go off to the left. If it was positive, it would go off and to the right. And what we're going to do is we're going to do a bunch of examples based on that, and you'll see that as we go through this. If you're ever really unsure about this, the best way to do this is somewhere over here, set up a table of values. Put your table of values for y equals negative 2x plus 1, and do your table of values for the square root of that. Now, that's a little bit longer to do. You'll just get faster with it once you learn the basic rules of this. Okay, flip to the next page. So let's make a chart to compare the values. So for instance, here is y equals f of x. It's just linear, right? So value of, right, we can look at this one. So when y is 0, right? When y is between 0 and 1, when y is 1, and y is greater than 1. So there's our invariant. Remember, our invariant points are the same on both graphs. So this is going to be the same point right there and at positive 1. So those are going to be our invariant points, and right there and at positive 1, right? They're the same points. When it's just slightly above it here, when it's between 0 and 1, right? Just slightly above it, and then it goes off and curves off to that when we're greater than 1. That's the general shape of them, right? And you'll see that. All right, third page. And then you get some weird ones. You get stuff like this. So what happens if you got, oh, here's a quadratic, right? Y equals negative x squared plus 5. So this is negative. It opens down. Plus 5 means it's shifted up. So our vertex in this case is 0, 5. It shifts down. Now, when we do this one, this has a really distinct look. So interesting thing is, this is the y-intercept. That doesn't change for this part here. Well, what is the square root of 5? Well, that's somewhere in there, right? Invariant points, right? It crosses the x-axis down here at root of negative 5 and root of 5, right? That's where it crosses the x-axis. So it's going to bump up and around, go through this point, and come down on this side. So it has a very distinct look. And you can see how we broke down the chart here. So the domain, right, is between negative root of 5 and positive 5. The range is between 0 and root of 5, includes those points. So you have to remember, like, when it looks like this in a quadratic, you get kind of a bump in there. And again, look at the minimum values, look at the y-intercepts, look at the x-intercepts. That'll help you do this. Okay, so this page here, there's a whole bunch of examples. So here's a general one. There's y equals mx plus b. It's just a line, right? So wherever it crosses, so this one crosses at negative 4, that's going to be the start of this. Our other invariant point is positive 1 here. It's going to do our little bump here. And you can look here. The y-intercept on the original was 4, so the square root of 4 is 2. And this one's quite easy, so you can see it goes off into the right that way. This one here, this is y equals x squared, just a standard quadratic, right? Y equals x squared. This one, when you take the square root of it, it's kind of cool. You get a straight line. Now, you can memorize these or do a simple table of values, and you can figure it out based on that. Right? This one's probably easier with the table of values, because that one's a little tough to memorize. Here's one here. So here is y equals f of x. So it's a quadratic that opens up below. So this one's below. So this part down here, this bottom part, just where it's gone, right? Because when you take the square root of it, it doesn't exist. So this one has 2 going each direction. So at 1 comma 0, right? And then our other invariant point up here, it goes off to the right. Here's our negative 1 comma 0, and this one goes to the left. Here's y equals 2x plus 4, right? So again, where it crosses the y-axis becomes our one invariant point, and then our other invariant point, it goes off and to the right. So it's really not that tough when you do this. And again, you can do table of values. Now, when you do this, if you choose this method to graph, when you draw the original, I didn't do it on here because it's really hard to do for this one. When you use this method, the original graph has to be a dotted line. So for instance, this black line would be a dotted line, and then you draw your graph over top of it. This black line would be dotted, and the other part is solid, right? That's how you do it to show which is the original, because we don't want you to get marks for the original. We just want you to get marks for the change on it, right? So if you draw it this way, if you do this method, dot the original, and then move on to the next piece. Okay, so that is, what was that one again? That was 2.1. There we go.